Hello folks, so in this video I want to talk about how you can use law of sines and cosines, but you might want to use one or the other in particular when you're finding angles in a triangle. So suppose you're trying to solve this triangle and you know already all the side lengths somehow. So either you're given SSS and you're working backwards to find the angles, or maybe you had SAS, so that would be alpha, B, and C. Then you found A using law of cosines, and then you're trying to find the missing gamma and beta, say. So since you're finding angles and you have one complete law of sines ratio, like this guy, you could use law of sines. But you could also use law of cosines, because law of cosines also connects an angle to its opposite side length. So which one should I use? I guess in this case, if I was to find beta, then we would use think about it, B here, that would be A, this would be AC, and then this would be beta. Okay, so essentially, again, the idea of this video is to talk about how one case is preferred over the other one, and I won't say which one, but I think you might have already kind of figured it out. So if I'm using law of sines to solve this, so let's say I'm going about this way, so I know this, this, and this, and I'm trying to find beta. Okay, so let's just work through an example. So again, solving this would always be the same in that your sine of beta is going to be sine of alpha over A, and then you would take inverse sine of whatever this number is, and then get your beta value. Okay, I just want to talk briefly about this, again, this ambiguous case, which makes your life somewhat challenging when you're doing these problems, and like why specifically you get those two solutions. Thinking about this now, I actually didn't look back at the videos for this chapter, so I don't know if I already made it, or I know that there's a video from that other channel that talks about the ambiguous case, but I don't know if they really explain it in detail as to why it exists. So that's kind of what I really want to do here. Okay, so let's just make an example. Let's suppose, that this expression on the left side of the equation is equal to 0.8. Just make that up. And so you're looking for an angle whose sine value is 0.8. Okay, let's draw this on the unit circle. So if I have some angle, call it beta, and so here's my unit circle, then, oops, let's make it a little bit easier for me to draw. So let's say it is this, not to scale. Okay, so if that is my sine value of 0.8, again, that's the y value on the unit circle. Say it's right there. Now from our picture, you can see that there's a second angle that has that same y value. And if I go over here into this quadrant 2, you'll get this other one. Maybe I'll use a slightly different color. I'll use orange here. Now, what angle is that? Well, using a little bit of kind of basic geometry, you'll see that this angle, not the orange one, is also equal to beta. And therefore, the actual beta 2, I guess we could call it, if this first guy is beta 1, the orange guy over here, that's beta 1. Then the new other angle that we're talking about that has the same sine value, beta 2, is just the supplement of beta 1. So beta 2 is equal to 180 degrees minus beta 1. And hopefully that's very clear as to why you get this ambiguous case. You have the original inverse sine value, because again, inverse sine will give you values in the right two quadrants, quadrant 1, quadrant 4. But there are other sine values that are other angles that have that same sine value. And that's why you have this ambiguous case of the law of sines. You might wonder then, how come we don't have to do this with the law of cosines? And well, we can use the unit circle to explain exactly that. So let's suppose I get to the same situation here. And let's say you did all the scratch work to solve this. I'm not going to do all the scratch work, but let's just say you did all the scratch work to get to the point where you say cosine of beta is equal to, again, we'll just use 0.8, I suppose. Now when I draw this, again, very similar to the other one, let's suppose your angle beta is right here. I guess I would try to make it a little bit to scale. That would be beta. I guess I'll call it beta 1, opening the door for possibly a second answer. On my unit circle, I'm looking for, okay, that's really bad. Let's draw another one. And a little bit better. Okay. Fix this. Okay. So this is going to be 0.8, this orange part right here, this golden part. So yes, there is a second angle that has the same cosine value. That angle, I guess I use orange in the other one. This beta 2 right there is equal but opposite. So this angle right here is going to be beta 2. And we can see clearly that beta 2 is just negative beta 1. So you get two answers, but how come with law of cosines you don't have this kind of ambiguous case? Well, the thing is that beta 2 is negative. And therefore, again, although true, like cosine of 45 is equal to cosine of negative 45 degrees, when we're dealing with, real triangles that we're looking at, there are no negative angles. It wouldn't make any sense. And so because of that, you don't have to worry about having several cases when you take your inverse cosine of whatever the value is, like you did have to do with inverse sine in the law of sines strategy. Okay, so hopefully that video explains why you would prefer to use law of cosines or a law of sines when you, provided that both of them are possible, when you're using them to find an angle in a triangle.